So again, the key with solving differential equations with substitutions is to basically, one of the things you can look for is anything that seems kind of out of place, that really you wish wasn't there. That's the first thing I would try. I know that's not the best way to approach anything, and obviously, this is not the most convenient way to solve differential equations, but sometimes it'll work. Okay, so here's another example. Okay. What here do we not like? Okay, this is kind of weird here, but ignoring the lny for a second, we could factor out a y and get a coefficient of 1 minus e to the x on the left, so that would be okay. The problem is this guy here. I think somebody said that. Natural log of y. So let's try that. Let u equal natural log y. Let's see what that does for us. So then du dx would be 1 over y times dy dx. So then dy dx becomes y times du dx. Does that make sense so far? So let's go ahead and replace dy dx back into the differential equation. So we'll have y times du dx plus y times u, which then equals y e to the x, which is good news because cancel out the y's, and now we're left with what looks like a linear differential equation with dependent u and independent x. And we know how to solve these. What do I do first? Integrating factor. So we'll do mu equals e to the integral of the coefficient of this term, which is just 1, dx. So integrating factor is e to the x. Multiply the entire equation by e to the x, so we have e to the x times du dx plus u times e to the x equals e to the 2x. Left-hand side, derivative of the product of integrating factor and u. Integrate. So we get e to the x times u equals what? 1/2 e to the 2x plus a constant. So then, let's say u, we can divide by e to the x, so it's just 1/2 e to the x plus c e to the minus x. This one isn't too bad to go ahead and solve for y explicitly, because we get natural log of y equals 1/2 e to the x plus c e to the minus x, and then if we exponentiate both sides, we get y equals e to the 1/2 e to the x plus c e to the minus x. Okay. All right, I'm going to give you guys an example to try. We'll talk about it first. X dy dx minus y equals x cubed over y times e to the y over x. Okay. Adrian, what would you try here? Well, what seems out of place? That's true. Okay. Got an AP Euro test coming up or something? I think you've kind of missed the theme. Yes, Rick? Yeah, something's kind of off here. That's a good place to start. Not so much having the exponential, but specifically the y over x. Does everybody kind of see that? Why don't you guys get going with that? So let's let u equal y over x. Try replacing this in. And let's see if you guys can figure out the solution. Those of you watching the video, okay, you guys don't look. I'm going to write the answer up here so that they can see it. Or just show it briefly.